This presentation is a little less researchy and more implementation oriented compared to Federal Highway Administration's presentation and the real interesting presentation from Norway. It's describing some of the things that we're doing here in South Dakota. Maybe preface this by saying South Dakota is a plain state. It's northern tier. We get a lot of winter weather. It's also a very rural state, and so everything that you see here will kind of be couched in that type of environment. I want to talk very briefly about 2 or 3 topics. The first 3 on the list: equipment improvements, route optimization, level of service, and spend a little more time on the last topics, which are traveler information, maintenance decision support, and variable speed limits. The 2 equipment improvements that I'll highlight here is more extensive use of tow plows. We did not invent the tow plows, but we've been adopting them quite a bit, especially for multi-lane facilities. We've also even used some in the Black Hills area, which is a more curvy type of road environment. But that has really helped us. The other innovation that we've tried is the lighting on snow plows, and we got legislation last year to be able to put blue lights on trucks in addition to the yellow and the strobe lights. And you see some photos here showing how that shows up. We've had good response from vehicle operators, from the maintenance vehicle operators, feeling that they are more visible, and also good feedback from the public saying that they're able to detect the plows more quickly. We're engaged in a route optimization project right now. This is not adaptive route optimization. It's more route optimization for our baseline routing. And looking at the preliminary results, we're just starting to get those, but it's looking like we might be able to save between 15 and 20% of the miles traveled to cover the routes. This is work that's going to be extending through the fall until the end of this year. But somebody earlier mentioned that there are acceptance issues whenever you change things. We're expecting that this will have some of those. We're having meetings with some of our maintenance units this week, showing them the early results, sort of doing reality checks on the routing that's being proposed, but seeing some opportunity for efficiency. And then another thing that's of interest to us, and I'm sure to other DOTs, is how do you define level of service? We've typically defined it by sort of input measures. We want to cover the road every 2 hours for our priority routes and every 4 hours for our non-priority routes. But those are more input measures rather than what is the output measure? What is the public experience when they drive on the road? One of the things we've looked at is using probe data to tell us what the speeds are on the roads, and make the association that the travel speed correlates with the road condition. This chart shows some analysis, and it was kind of a logic analysis, but when the speeds are between 0 and 76% of the free flow speed, the average speed is, then we have a pretty good probability that the road has snow on it. And we're not using that to decide whether we should go treat the road, but it would tell us that the road has been in a snowy condition. Between 76% and 87%, we really don't know. It could be either or. And above 80% of the free flow speed, we're seeing that the probability is very good that the roads are clear. So we're looking at this as a possible way to transition to a more performance-based level of service. And I know that other states in our region are trying similar things and trying to find a way that's meaningful to define and measure level of service. I'll transition here to, let's move this out of the way, to traveler information. We do have a 511 website. We have iOS, Android apps. We have text and email notifications, Twitter feed. We still maintain the 511 phone service. And something we've added recently is putting kiosks in our rest areas and our commercial vehicle ports of entry. The screen on the lower left is just the screen that's for our website, and you can see that it depicts road conditions by shading the roads different colors. The clouds are environmental sensor stations that have weather observations in them. Some of them you see have numbers, which would, in this case, would be temperature. Others have little numbers saying there's actually 2 environmental sensor stations there, and if you zoom in, they'll separate. See here. Part of the information that we provide is from environmental sensor stations. We have 132 of these located statewide. All of them have high resolution infrared illuminated pan-tilt zoom cameras, so we get images day and night, and then they have weather sensors. We have not used pavement surface sensors much, and the reason we went away from that is it seemed like every time we put a sensor in, we would overlay the road the next year. And we do have non-contact sensors at one location, but we're primarily observing the atmospheric conditions at these sites, and of course the camera images. This shows one of the kiosk displays. The kiosk displays scroll through different screens. This particular screen shows cameras along I-90, shows where the traveler is, and so they get an idea of what the conditions are along the entire route that they're going to be traveling. There are several screens. I'm just showing a couple. This one is wind speeds, which is of particular interest to commercial vehicle operators. And this wasn't a particularly windy day, except down in Nebraska. It was, the wind speeds were in the 30s and up to 40 miles an hour. We have high wind speeds a lot. And so having 60, 70 mile an hour straight winds is not that unusual. And so this is really important to commercial carriers. I want to talk a little bit about the maintenance decision support system, and Dave Johnson mentioned this. This has been a pool fund study for a very long time. It's actually been a series of pool fund studies, but started in 2002. The states were Indiana, Minnesota, and the Dakotas. We have been the lead state throughout the study. We have state DOTs, and we have a couple of local agencies that are kind of friends to the pool fund study. Each state contributes some funding to help fund the development of the MDSS and scientific studies related to the basis of MDSS. DTN is the contractor for the pool fund study. All of the states on the map have participated in the study at one time or another. The ones that are shaded more dark blue are the current participants in the study. And the premise of MDSS is that if you know the characteristics of your road and you know the current conditions on the road, and you know what the predicted weather is, and you understand how snow and ice and chemicals behave, and if you know what resources you have to work with, then the MDSS can recommend the treatment type and application rate and an optimal timing for that application, and predict the road conditions, whether you treat or whether you don't treat. And so the analysis of what happens if you do treat or what happens if you treat with option A, B, C, or D is really the analysis that's going on with MDSS. And the cartoon here illustrates the factors that are considered in MDSS. So the red arrows represent heat flows, and they can go up or down into the atmosphere, or from the atmosphere down into the pavement, or from the subgrade up to the pavement, or the other way, depending on what time of year you are. There's even a little bit of heat generated from traffic. The blue arrows are material, and the material could be precipitation, it could be salt, it could be grit. The material is moved by the plow, It's also distributed by traffic, and it runs off the road because of the crown of the road or the grade. And all of these things are considered in the analysis of MDSS. It's a numerical simulation of what's going on the roadway. And this illustrates the simulation versus the roadway condition. This is a case on Interstate 29. It's a photo in North Dakota. The blue band illustrates what MDSS was predicting to be the distribution of material on the road. The photograph, of course, is illustrating what the actual distribution of material was on the road, and also showing here the percent ice and the temperature of the roads. This was a fairly warm event and a slushy snow. Of course, the better that we can predict the road condition and the better we can predict the behavior of the treatments, the more meaningful the recommendations are. The MDSS provides a user interface that has rich information about the road conditions and the weather conditions that are going on. There are alert dashboards, and it's a very rich user interface. Part of the user interface is graphs. This can also be represented in chart, a tabular form, showing all kinds of measurements: wind speed and direction, probability of percentages of precipitation, precipitation accumulations, dew points, you name it. And by examining this, you can get a really good picture, excuse me, of what's going to happen going forward. This illustrates some time prior to the present and also up to 48 hours future from the present. There is onboard instrumentation on snowplows that help to report what treatments are being done. You'll see the user display in the left photo. There's a road temperature sensor, an infrared sensor looking at the road, ambient air temperature sensor. And on the snowplow, you'll see a hardened mercury switch, which tells us whether the plow is up or down. And all of the plows on our trucks are equipped with the sensors. Sometimes there are as many as three blades on a plow. And then, of course, we have GPS and cellular communication. The right image is more the user interface inside the truck. This happens to be focused in an area which isn't South Dakota, but you'll see the type of information, what the truck is doing, and then there's also a screen that recommends what treatment should be applied based on the MDSS analysis. And this goes directly into the operator's truck. We don't in South Dakota have a heavily dispatched system. It's more of a system where each truck operator is making decisions about what to do on the roadway, informed by the MDSS. One of the decisions we had to make is whether we would move from kind of a trial deployment of MDSS, where we had about 30% of our roadways in MDSS, or go to a statewide adoption, or move away from MDSS altogether. And we did a study. It was done by Louisiana State University, but looking at the benefits and costs of deployment statewide. If we consider just the direct costs, the agency benefits and the agency costs, the benefit cost ratio was just a little bit better than 1-to-1. If we considered the safety and road use costs in addition to direct benefits, and in addition to direct benefits, then the benefit cost ratio raised to over 3-to-1. And so on the basis of this research, we decided to expand MDSS to all of our state highways and to expand the mobile data collection to our entire snowplow fleet. And we're incrementally adding the onboard instrumentation to our trucks. We're about 2/3 of the way to having all of our trucks instrumented, and would expect to complete by the end of next year. Last topic I want to talk about is variable speed limits, and South Dakota has not done these before, so this is new work for us. The first place we're going to deploy this is on Interstate 90. on a section from Sturgis to Tilford. Sturgis, of course, is the location of the motorcycle rally, and it's on the north edge of the Black Hills. It experiences a lot of bad winter weather, but it also has some unique traffic characteristics, including the Sturgis rally. The peak attendance of that was 750,000 bikers in 2015, and this year we had between 500,000 and 600,000. So for a couple of weeks in the summer, it's a very different traffic environment. So we're trying to address weather challenges. The middle picture here is actually a South Dakota event where the trucks turned around and backwards on the interstate in a winter event. So we are installing variable speed limits on this section of road. We have another section on Interstate 29 in the east part of the state that is sort of happening in parallel. It'll be done right after this one, but it will be a regulatory speed limit. It won't be advisory. It took special legislation to enable us to do this. Prior to this, the Transportation Commission had to meet to change the speed limit, which of course completely impractical for variable speed limits. We're going to be measuring surface condition on the road. We're going to be measuring visibility and also precipitation and other weather conditions, temperatures, and so forth. And beyond that, the traffic speed and volume, because one of the indicators that a variable speed limit is warranted is that the traffic speeds begin to drop and the traffic speeds disperse. You have some people that are still driving 75 miles an hour and some people that are driving 30 miles an hour, which of course is a danger in itself. All of our speed limit signs, static speed limit signs, will be replaced by electronic speed limit signs. We're hoping to reduce winter crashes and fatalities by at least half. And we're basing this largely on Wyoming's experience, who has used variable speed limits for more than a decade very successfully. And so we're really in some large part imitating the good work that Wyoming has done. One of the things we were interested in is whether the public would be receptive to variable speed limits. And so we first asked this question in 2018, would you favor temporarily lowering speed limits to match road conditions? And 2/3 of the respondents to our customer satisfaction survey, this is something we do every 2 or 3 years, said yes, they would favor that. About a quarter, 23% said they would not, and there 10% weren't sure about it. We repeated this question again in 2021, and the results were essentially the same. The yeses went up a little bit, the no's went down a little bit, the don't knows reduced, but essentially it was the same very strong level of support for doing this among the public. And of course, this is something they have not experienced in South Dakota before. So it's asking, would you, not do you like it now that we have it? We'll of course be monitoring this after we do put it in. And I wanted to show you this section. This is the section of roadway from Sturgis to Tilford. Sturgis is on the upper left. It's a city of about 7,000 people. Interstate 90 goes through, comes down, and there's a very small town on the lower right, which is called Tilford. But we are putting variable speed limits everywhere in this photograph or cartoon depiction. Everywhere there's a 45, it means that there's variable speed limits. The normal speed limit is 75, so as you leave the section, it'll go back to 75. And likewise, down the other end, on the east end of the project, it'll go back to 75 going eastward. But in addition to the variable speed limits, we're putting in 3 environmental sensor stations. These are the towers. We're putting in traffic detection to get the traffic speeds and dispersion of traffic between every set of exits and between every interchange on the roadway. We have 2 dynamic message signs in this roadway now. We're adding 2 more. to give better instructions to travelers. The corridor will have full camera surveillance. Not that there are a huge number of cameras, but by strategically placing the cameras, we'll be able to see every portion of the corridor by zooming to them. Another thing that is new for us, we've had road closure gates at Sturgis where these red signs are, both Sturgis exits, but they're manual and you have to go out and crank them down. And these will be automated so they can be controlled from the traffic management system. Another thing which is more related to the Sturgis rally is queue detection on the exit ramps at 3 interchanges. And the last thing that I have noted here is we are replacing our commercial vehicle port of entry with actually a new physical port of entry, and also a replacement of the electronic screening system. The electronic screening system is going to be have the addition of tire anomaly checking. This is an in-pavement set of sensors that measures the tire pressure of the trucks crossing it and warns when a truck has a underinflated or uninflated tire, and then thermal brake checking on the inbound ramp to the port of entry to look for inoperable or defective brakes. So this is probably one of the, well, it is the most intensive deployment of intelligent transportation devices in South Dakota. This is going to be installed next summer. The plans are just nearing completion right now. This is my contact information. It's kind of a quick overview, but so much of what we do in ITS here is related to road weather management, and just wanted to show some examples of a fairly small rural state applying some of these techniques in operation on highways. And Luan, I'd be happy to take any questions if there are some.